Sounds like we are a go. Awesome. Hello everyone, welcome to this session. My name is Jimil Patel. I lead developer advocacy and technical product marketing at Intuit. To deliver this session, I'm joined by Christy. Christy, do you want to introduce yourself?
Hi, my name is Christy Bergman. I'm a staff developer advocate, and I focus on cloud, microservices, development, and AI.
Cool. So today we are here to share with you how Intuit is building what we call the Paved road that standardizes developer platform powered by open source to accelerate developer velocity across thousands of developers at Intuit. So here's what we'll go over today. We will talk about why we built a paved road and why open source is key to that vision. How we are accelerating both the inner loop and outer loop, and we have some cool demos for both areas, how we are innovating in those areas and making developers go faster. And then finally, we'll do some key takeaways and lesson learned from our journey. So without further ado, let's get started. But if you haven't heard about Intuit, who here hasn't heard about Intuit? Okay, looks like you all have. Intuit is a company that creates financial technology company that creates products like QuickBooks, TurboTax, MailChimp, Credit Karma, and these products collectively serve over 100 million customers globally, process over $1 billion in tax refund, $2 trillion in invoices managed, and process over 18 million US worker payroll as well. But today I'm not here to talk about taxes or invoices. I'm here to talk about how we scale an AI native platform for over 8,000 technologists to move faster, or roughly 8 times faster, without losing their minds over Kubernetes YAMLs. And building for 100 million users is not easy. That means your dev platform needs to be rock solid. We nearly run 3,000 production services with 350 Kubernetes clusters, 1 million GPU cores, and all such that the developers don't have to think about YAMLs at 2 a.m. in the morning. We also have roughly 50,000 namespaces. Basically, we run more pods than an alien invasion movie. And at this scale, moving fast is not a luxury, it is a requirement. And that's what we're going to show through our platform today. So let's talk about why paved road and why open source. So if you think about what a developer of today has to deal with, this is a React developer, and you'll see why he's sad. This is someone who wants to build great user experiences, but before they get to writing code, look at all the different things they have to deal with. They have to deal with Jenkins pipelines, AWS permissions, Docker builds, Kubernetes deployments, Terraform configurations, VPCs, Kafka, and the list goes on, Nginx, load balancers, whatnot. But hey, I'm a React developer. I don't care about these things. But if you work at a large corporation, chances are you have dealt with this where you are going through so many loops and hurdles just to get your code deployed. And that's what we that's what we saw with our developers, and kind of to solve for that, we wanted to build these things called paved roads. Now imagine that all of the infrastructure, the pipelines, the scaling, everything was paved for you. So that's why this React developer is happy, because instead of reinventing the wheel, all they do is run their code or hit deploy, and then automated builds kick in, and he doesn't even know what networking is. He's like, what is networking? Auto scaling is done for them. The applications are secured by default, and what you get back is a URL that just runs. And that to a developer is a paved road. Instead of every developer reinventing the wheel, we give them consistent frameworks and consistent, secure, automated path to production. At Intuit, this is built on top of open source. It is opinionated in the right ways, and it lets developers focus on what they do best, is building for customers. So here's how it has resulted for us, or here's some of the results we have seen. From 50% of developer time being spent on outer loop activities like configuration of Kubernetes or setting up load balancers and VPCs, now it is all done for you. So they're spending half the time on the same things. We used to see 1 in 5 developer support requests about Kubernetes knowledge, not having Kubernetes knowledge. And from having these 1 in 5 tickets, we have went to virtually no tickets about infrastructure knowledge. Incidents, 1 in 3 incidents happen because there was a misconfiguration on AWS or misconfiguration somewhere. And we have went from these incidents happening to none of these incidents happening because of configuration issues. And lastly, we've saved a lot of money because when you ask developers to provision infrastructure themselves, chances are they will over provision because they don't want it to fail. So, and it's not like their credit card's going to get billed, so they're going to say like 10 CPUs and as many gigabytes of RAM as I can provision, just because my app keeps running, right? So that's where scaling and auto scaling for them has resulted into a lot of cost savings for us. Another key tenet to building these paved roads is open source. So according to a Harvard Business Study, 2025, open source yields $8.8 trillion in economic value across the globe. This means if these companies, all the companies leveraging open source code, were to instead go and build all these software and invest time in maintaining that, that's how much that would cost. And to a typical enterprise like Intuit, they would be spending 3.5 times more than what they are today if they were to use commercial off-the-shelf software. So we are not different. We are not trying to reinvent the wheel. But you will also feel open source is hard because you have to build a community, you have competition from vendors that have funding, you have to make sure the code is secure by default and your security approves it. You have to get funding for these projects and make sure they are sustainable. So these are some challenges that people typically see with open source, but that's where we have built this framework, what we call the flywheel, open source flywheel, that kind of helps us solve for these challenges. So what happens is, Intuit builds these open source or makes these open source contributions to projects that we maintain, and we use them for key parts of our internal developer platform. We then have dedicated engineers to some of these projects where they contribute features that we want back to the project. And these are also based on real learnings that we have seen in the market. Then we come to events like this, All Things Open, and other cool open source events, and grow the open source community, evangelize the work, and evangelize the new features that we have contributed. And then finally, we build community champions who are pseudo working for Intuit because they help us grow these projects, build new features that we were expecting. And this flywheel helps us make sure the projects we invest in and we use are both healthy as well as useful to us for the long run. So open source combined with a paved road leads to winning, essentially. And as we were building these paved roads, we did some studies where do developers spend time on. So this is kind of our development lifecycle. At the very left, you see customer inputs, which are problems and goals that our leadership builds for us. That goes through the product and requirement lifecycle. So you product managers and designers research, build requirements, design, and do user testing. 25% of time is spent here. And then then once you have the user shovel-ready designs, they are shipped to developers where there's the inner loop, where you build, test, debug in your machine and finally deploy your code. And there's the outer loop, which is release, deploy, operate, and monitor, which is where once the code leaves your machine, it's kind of getting deployed to production, E2E, whatever environments you might have. And that's where 30% of developer times is spent, which is 30 and 30, and then the rest, 15% is spent in meetings. So the reason we built these paved roads is we wanted to focus on this 60% and how to make this go faster. So for this purpose, we have some innovations in the inner loop and outer loop, and I'm going to start with the inner loop, where Christy is going to show some innovations on how we made that go faster.
All right, so Jimil talked about where developers are spending time. Let's see if I can get this to click. Oh, shoot. Okay. Okay. All right, so I'm going to show what the inner loop looks like for a developer. This is the core developer workload, architect, code, build, test, debug. And so every developer has 4 main challenges, like if they get a new laptop, the time it takes hours to a day maybe to get their laptop set up. Maybe they need to switch environments with different dependencies. All of that is a high cognitive load every time a developer needs to switch projects. Their laptop is a resource limit, so especially for like maybe a heavy application like payroll, which needs Microsoft SQL, because M series laptops are not super compatible. They have to run an emulator through Rancher, which consumes 100% resource capacity of their laptop. And then a lot of developer environments, when they set them up themselves, are not necessarily the same across for their teammates or the same as pre-production or production environments. So with that, let me show you what this looks like from a developer point of view at Intuit. All right, so I'm going to show you starting with the inner loop. I'm here on my Cloud Workspaces dashboard, and I could create a new workspace just by pasting the GitHub. And you'll notice that it automatically detects my tech stack and recommends a size for me, and I could click Create Workspace. Our goal at Intuit is this should be from 0 to spun up within under 2 minutes, with at or equal what or more of what a developer could have if they spun it up themselves. Now that would have taken a couple minutes to spin up, so I'm just going to go to one that I already have running here. So yeah, and you'll notice here also probably your favorite IDE is supported. This is running on Docker and Dev Containers open source. But we've got, we could be running Visual VS Studio on either desktop or cloud or an Air terminal or PyCharm for Java developers who want to use IntelliJ, or Cursor or Windsurf. I'm going to open Cursor. All right, so you can see that all of my personal settings are saved. I got a little cat running around. I've got my background set to off-white, which is supposed to be easier on the eyes. I have full control. So all of this was template code. I chose, in this case, it's Python, and I chose our agent developer kit as a template. So I'm all ready to do AI if I want. And then this, for example, I have full control over the Docker file if I want. For example, oops, where did everything go? Sorry. Yeah, for example, if when I spun up, I added a little note to myself. So just to show that you can do whatever you want with your own Docker file if you want. Also, when you look at the code, you'll notice that besides the Docker file, you've got a dev container, which is standard for everybody running on dev containers, to customize things. We've also got these written for us, the Windsurf rules and the cursor rules. So in this case, the cursor rules look like this because we're expecting this to be a Python agent developer. So if I go to my README, for example, I see that some of the steps that I'm supposed to be doing, so I lost my place here. is supposed to be doing a poetry install, activate environment, poetry install, and set my Python path. So that's a handy thing for this dev container to do. So I've made this so, for example, it automatically sets my virtual environment, installs some libraries that I know I'm going to need, and sets up my Python path so that when I go into this shell, I'm already there. I didn't have to do any of those steps. All of this code is already hooked up internally to the Intuit service fabric. Let me just try to toggle. One of these days I'm going to get faster at toggling. So this is what it looks like when you're in our developer portal. You have access here to the AI and ML models. You have full access to our Spark tables through Databricks. You can do data discovery. Yeah, and then, oops. And then if I go to create one of those templated code paved roads, you can see that I have a choice of programming language as well. I could have chosen Java or the GraphQL Java version, Python, straight up Python, or the Python Agent Starter Kit, straight up Golang, or the MailChimp Go flavor of Go. Okay, so now just to prove that I am fully connected to the internal Intuit developer system, I'm going to go ahead and run a notebook. So let me restart this. And fingers crossed. Do everything, run everything. And, oops, so I need to go here again. I need to go to doc. Go again. I'm going to grab my credentials. Okay, so you can see here I'm just adding a few AI types of tools that I need, OpenAI and LangChain, and I'm gonna install our own internal auth tools for auth headers. I'm going to go ahead and save my app ID, experience ID. These are internal things into my environment variables. Generate these auth headers on the fly because we have ever-changing tokens, which is hard to do manually. And then I'm going to send a question and to our backend URL for our own hosted models. So in this, for example, I could send it to OpenAI with GPT-5 Mini, for example, and I asked it the question, tell me about my marginal tax rate, and voila, I get an answer back, or more pretty printed, looks like this. Now, I can also, another handy thing here is, I need to watch my time. I think I'm getting too wrapped up in the developer experience. Okay, so another handy thing is this port forwarding. So basically these ports are being forwarded so that you can access them from your front end. So this was another like stuck point for a lot of developers, and now it's done for you. So we can see here that port localhost 8090 is forwarded. I can go to, darn, where's my handy copy paste? This one. So I will go ahead to my terminal and paste that in and make this bigger. And you can see here it is running a little fast API server on port 8090. With that, I should be able to now access this as a backend service if I want. So let me go to so I'm going to do private auth plus, which means I'm on the internal Intuit network. Authenticate in. close this in full screen mode. Okay. Showing my auth headers. So these will expire very quickly, so that's why I need to regenerate them all the time. And then I can go to my Cloud Workspaces, open a, this one, the web terminal. And I'll go to, you can see that I'm running in my virtual environment. And then I go here and I copy paste those headers into our curl. And here you can see it's basically a localhost 8090 because of that port forwarding invoke. So if all goes well with the demo gods today, I should be able to ask via curl, so this would be like as if an external service was reaching my backend service, and it asked the question about marginal tax rate, and so I get the answer. So yes, it worked. Now let me go back to the slides. Okay, that was a brief look at what the inner loop looks like for a developer at Intuit. And so next, I spent a little too time getting too excited there with the showing off the developer experience. So I'll just go through this quickly. So the outer loop is at Intuit, we've created, so this infrastructure so that all of your deployment and monitoring is also done for you. And because we're at ATO, I'm going to point out some of our open source here on the outer loop as well. So all of our services are built as microservices on top of Kubernetes, and we have Intuit Kubernetes system on top of EKS, an event bus for Kafka, built on Kafka for streaming, autoscaling, Carpenter for node autoscaling, NemoFlow, which Jimil is going to talk about, for data streaming, Argo rollouts, and Jenkins. And we also, Intuit also open sourced its own Istio for traffic control plane management, which also uses Envoy, built by Lyft for the open source data plane management of traffic. Okay, so really quickly, I'm going to fly through this. The autoscaling normally would be done if it's static, then a developer might set them, then they tend to forget them. And this leads to resource waste or not enough resources in case of a peak application. And there used to be dozens of YAML files that developers had to make these settings in. Looking at the problem we had of time-dependent autoscaling, Carpenter is there, but it only handles the pods. I mean, the reverse. It only handles the node autoscaling. So we built on top of Carpenter, and that solved node autoscaling, but we still need pod autoscaling. There's an open source project called Kita, Kubernetes event-driven something autoscaling, and so that's what was the inspiration for Intuit's intelligent pod autoscaler, which is time dependent. You can think of this like cruise control on a highway, except the speed limits are varying by time of day, for example, if you could imagine that. So you've got varying speed limits. These are the baselines that the cruise control, which is our autoscaler, needs to stay inside of. And I'm just gonna, I think I'm not gonna be able to show a whole bunch, except I'll just give you a quick brief look. Oops. Go back to my service, go back to here. And this is also what, there's a lot of stuff here for the outer loop developer into it, but like this is, for example, one of our namespaces, which is an end-to-end or called pre-production. And you can see here If I go to the earliest pod size, it was, I picked maybe a variable called container memory limit app. You can see it was initialized at 2 gigs. And if I go to the latest one, I can see for that same variable that it changed from 1803 to 1479. So it's been stepping down. And this happens automatically. As an outer loop developer, I didn't have to do that. And I think I'm gonna hand it over at this point back to Jimil. Let's see, where's the slides? Yeah.
Okay, so Christy showed us in terms of our inner loop and outer loop, what are some of the innovations that we've had. I'm going to show you some other innovations we have had on top of Kubernetes, specifically build analysis. So as you build stuff, we use Jenkins for our CI pipelines, and when a build fails, a lot of times developers go in and restart the builds. The process usually is go to Jenkins, open Blue Ocean, start sifting through the logs, and then try to find what's failing and then Google it. And you keep repeating it until your build passes. So this is something we've all experienced. And as a developer at Intuit, most of our developers complain about this loop. And it takes a lot of time because builds take a lot of time to pass. So instead what we have done is created build failure analysis. So I am also going to show you how this part works. So I'm on a repo where I have a PR ready. I'm going to open up a pull request and just create a PR. Every time a PR is created at Intuit, automatically there will be security checks that will happen. There will be some other linting checks that will happen. And if things go well, our Jenkins pipeline kicks off. I know this build is going to fail. I intentionally added some code there that will make this build fail. So let's go into the build itself. And I'm going to keep this tab open on the side. So this build should fail very quickly. And if this doesn't work out as I expected, I have a pre-failed build that we can go through. But what is going to happen is as the build fails, we create GenAI summarization of what has failed in the build. And we show it at 2 places. One is in the GitHub PR itself. So you will be able to see in the PR itself where this PR build has failed and why it has failed. These are the probable root causes. And as a developer, you are able to copy paste the root cause right into Cursor or Windsurf and ask it to fix it. You will also get an email suggesting what has occurred in this build and what caused it to fail. This usually takes 2 minutes, oh, the build passed, wow. So this is a pleasant surprise, but luckily I planned for this situation before. So here's an example. So here's a commit I made last night, and then you can see here you will get the GenAI failure analysis. In this case, I did not have enough test cases passing. So it's saying Jacko coverage for the line coverage might have fallen below 85%, which is the standard for tests passing. The same thing also shows up in my email. So I get a similar email that is automatically generated. It comes with related resources as well, and these resources might be Intuit internal docs on how to fix it. So every time a build fails, you get the failure analysis in the PR as well as in your email. And that has helped our developers succeed a lot more, and instead of context switching over and over, they would just get notified when the build fails instead of waiting on this blue ocean screen for things to pass. Maybe it fails on this stage, but we'll see. I'll keep this open while I talk about the next feature. So this is on the Jenkins side, but sometimes your builds also fail on the CD side. So I'll show you an example there as well. So this is the Argo CDE instance, and I am going to show that this API is working. So here's the API, it's just a simple orders API. I've also created some endpoints that will create out of memory error and do some memory leaks from here. So if I hit this endpoint, it will leak 50 megabytes of memory, and if I hit this endpoint, it will generate an out of memory error. That's why I'm getting 500s here. So I'm gonna keep making 500 errors on this and keep pushing this application so that my Argo CD starts crashing, and I want to also leak some memory. So these are, I'm just making synthetic errors because I wanted to show you what happens when things fail. Looks like I've created enough errors that I can't even reach the server anymore. So let's go to Argo CD, and then I'm just going to refresh and see what's happening there. So as you can see, it's in the progressing state right now, and seems like Argo CD has also detected that this has started to fail. Let me try one more time to make sure. Okay, so now we can't actually get to this pod, and again refresh. So Argo CD has started to break this. So we have added this new feature called Argo CD Assist. If you hit that, you can see automatically it creates a summary, and this was summarized 2 hours ago. I can run it again. But what it does is it sees through all the application logs of the deployment. There could be multiple deployments in multiple regions as well. So it collects all, and Argo CD being the deployment engine, it can collect all the logs and analyze these problems and errors, and uses GenAI to generate a response here as well. So a lot of times developers come here, they're opening logs, they're opening rollouts and trying to figure out what is going wrong. And as you can see, it knows the probable cause, which is the out of memory leak space. Readiness probes are failing, and then the rollout is not healthy. Generally, it has not happened yet, but Argo CD will spin up a new pod here and then route traffic to that once this is once a specific time has passed. So it should auto recover by itself as well. Let's see where our Jenkins pipeline is. It failed. Oh, okay, perfect. So it actually failed. The initial build passed, but when we did the Docker build, that failed. And let's see if this intentional build failed as well. I think it did. So this is just now. This is now. Yeah, I think this was the one that we opened, and as you can see that we have unresolved dependency, and this was 1 minute ago. So we got the GenAI summary, and I should have gotten an email as well. Let's just quickly see. Yeah, this is the email that I got. I'm on Pacific time, so here's kind of the analysis of what was not available, incorrect repo config. I made these errors myself, but this is kind of to show you what happens when builds fail. So that was the build failure demo. You can see the email summary and the PR comment, and you get the summaries, and we also saw how it shows up in Argo CD itself. The next thing I want to talk about is canary rollouts. So this is the Argo CD side of things and how we do deployment set into it. There is a stat somewhere that I read. This is the technical number here is 80%, but I couldn't find published papers around it. But in reality, 80% of P0, P1 incidents that happen are induced by change. Meaning someone somewhere decided to change something, did not test it and push it, and things seem to work, and then things go wrong all of a sudden. So most of the incidents that happen in large organizations are due to changes that developers make. What if we could have, while these changes happen and the incidents happen, we could have 99.99% of user availability? What if we can reduce the number of these incidents by double digits? What if you can reduce the time to recover to less than 5 minutes? What if you can reduce the impact to customer to be less than 5% as well? And these are kind of questions that we started with, and what Argo CD and Argo rollouts is helping us achieve through what we call progressive rollouts. So let me show you, and there is no live demo for this use case, but I'm just going to show you how it works. So this is, like Christy showed, this was where our a developer can go and look at their existing service. This is part of our internal dev portal, or internal IDP, how people refer to it. Every deployment in every environment has this deployment details button and when it was synced with Argo. If I click on the deployment details button, I can see what happened in the canary rollout side of things. So on the left, I see the different revisions, and on the right, I see the different steps. So what happens every time a developer pushes changes upstream, 6 steps happen. So first, it sets the canary weight to 40, set traffic weight to 25%, and then what happens is it runs an analysis run, and this is what an analysis run looks like. You can customize this, so you can say my error threshold is X%. Here it will check for 10 successful attempts. So every time a deployment happens, only 25% of customers get that deployment. While that is happening, an analysis run happens where you check for 10 successful events. If those 10 successful events are successful, or if you get failures, things go differently, then it goes to the next step, which is weight set to 65, and then again traffic weight is 50%. So now 50% of customers are getting this stable release. And then the final step that I can't see here is essentially like 100%. If at any of these stages, any of these analysis run fails, it rolls back to the previous version. So every time there's a change in use incident, like it just rolls back to the previous version versus expanding the horizon of that incident to all of your customers. And this is what we do, this is how we progressively roll out applications. This is very effective on front-end applications, but can be also effective on the back-end side of things as well. And then the analysis run and the thresholds is your secret sauce. Essentially, for front-end applications, you would have to see what kind of user interactions are failing. And then for back-end applications, you would see error rates on API calls and those kinds of things. And then you can decide like 3 error means rollback, or like 10 error means like some applications cause errors by naturally. So you have to figure out like what is your error rate that you want to roll back upon. We mentioned this project called NumaFlow. So we have open source another project which is an event streaming platform on Kubernetes. So how this whole thing works is in the center of everything is Argo rollouts. Every time the release happens, there is like a canary release which has 10% of the traffic, and it will have another revision, and the 10% of the traffic gets revision too. When this happens, we have a data store. We use Prometheus as well as other data sources. And all of these logs are in real time streamed to our event processing engine with NumaFlow. NumaFlow has an ML pipeline, and it ingests all the logs and in real time produces an anomaly score. This anomaly score is returned back to our rollouts, and you detect your threshold for anomaly scoring. And if the score goes above certain stage, you go back to the stable version. Otherwise, you keep increasing the dial in the canary version. And that's how a lot of our incidents are just solved before they happen. Our mean time to recovery for these kinds of incidents is less than 5 minutes. And every team that has adopted it has kind of seen results as in months or sometimes even days. Okay. That brings me towards the end of the session. We have 3 minutes remaining, so I'm just going to talk through 4 takeaways in case you were like, what is this session about? So one is velocity comes with simplicity. If you are in a stage where your developers are bombarded with those circle of tools, then you have to change it and make it simple. Make them learn 3 things, not 50 things. So think about removing friction through making things simple. Second is open source flywheel. Don't try to build everything yourself. Rely on the open source community, and in order to effectively use open source, you have to contribute back. So as you learn things, as you think this feature is missing from open source, don't just abandon that project and find a new one that supports your use case. Try to contribute it back, and share your story. Chances are others have the same problem, and they will work with you. Third is AI is not just coding assistants and chatbots. A lot of times when people think about AI, they're like, Cursor, Windsurf, or like chatbots. But you can integrate AI into your build cycles. You can integrate AI into your deployment cycles and try to figure out how to help developers in those stages as well. In the future, we would love to bring some Jenkins logs and Argo CD logs right into the IDE, so people can just ask why did my build fail, and not have to go to these tools to find out why my builds are failing. So that's kind of the next leap from here, where the chat agent is connected to your deployment tools, your Splunk, your observability, and kind of give more smart answers based on what is failing. And the last is learn from the platform community. That's why we are all here. So I'm here to learn as well. If you saw something that reflected well and kind of have some similar ideas, I'd love to talk. Our team would love to incorporate some of these ideas. Community is how this whole dev platform was made. And I think you should also lean into us as well as the product community to build these cool things. With that being said, Intuit's the recipient of the End User Award twice now, in 2019 and 2020. We've created the Argo project, is something Intuit created as well, and we created it just like this, where we're trying to solve something cool and then we realize others have the problem as well. NumaFlow is the anomaly detection tool that we use for event streaming. And we are also end users of hundreds of these open source projects, not just these. We use Kubernetes, Istio, Envoy, GraphQL, Node.js, you name it, we use it. With that, thank you so much. Here's the URL to find some of those projects. We have a booth here. We can show you the demos of any of these things more in detail. And if you have questions, we are at time, but Christy and I will be around to field any questions. Thank you so much.